All right. Hello, everybody. We're going to be looking at lesson 7 here. Now, for this lesson, it's a whole bunch of math. So I need to demonstrate it on my whiteboard. What's been happening lately, though, is if I go back and forth between the computer screen and the whiteboard, it flips this and messes it up. So for now, I have to make separate videos. So this video is just going to be me on the whiteboard. I can't show you my screen, but I'm opening up the lesson 7 PowerPoint. So if you want to follow along with these examples, I'm doing examples out of the lesson 7 PowerPoint. So you go into the classroom, go to materials, and open the PowerPoint for lesson 7. So with this, the first thing it says, I'm looking at a definition. It says a conversion factor is any factor equal to 1 that consists of a ratio of 2 units. That's a conversion factor. We're going to be using these all over the place in chemistry. All right, so let's look at this first problem. Example, you look in your fridge and you see 6 eggs. So we have 6 eggs. And what we need to do is we need to tell our mom there's a half dozen eggs. How did we go from 6 to a half dozen? How do we figure that out? Now, a lot of you do this in your head, but the actual math we're doing is we're going like this. We're making a conversion factor. A conversion factor is going to be a factor where the inside of this is equal to 1, so we can use as much as we want, but on top we'll have 1 unit and on bottom we'll have another. The way you do it, we want to figure out 6 eggs. We want to tell how many dozen the 6 eggs equal. So 6 eggs is how many dozen? So what we'll do is we want this unit to go away. So let's put eggs on bottom, and we're turning eggs into a dozen. Now ignore everything else. What's the relationship between dozen and eggs? A dozen equals how many eggs? Well, 1 dozen equals 12 eggs. This right here is a conversion factor. And it might seem kind of pointless now when it's something as easy as turning 6 eggs into into a half dozen. But when it gets to hard chemistry stuff, this is extremely helpful. Because look what will happen. The units cancel out. Eggs is on top, eggs is on bottom. And all that's left is dozen, which is what we want. And let's do the math. On top, we do 6 times 1, which will give us a 6. And on bottom, all that's left is a 12. So we have 6 over 12, which is 1 over 2. So our answer is a half of a dozen. Okay, you see how that works? Let's go to another example. Let's do, so we have 3 different people measure the length of an object. So what we have here, we have one person, or there's 2 different groups. Group A measures the object to be 2 meters. Group B measures out the object to be 200 centimeters. And then group C comes up with 2,000 millimeters. Let's convert all of these to a meter. So this will be our final answer here. It's 2 meters. And what we're trying to do, did anybody make a mistake? Did they all say the same thing? So all of these should end up equaling 2 meters if all of the groups did it right. So let's go ahead and convert centimeters into meters. So let's use a conversion factor. So it starts in centimeters. We want it to become meters. So let's take centimeters and put it on bottom and put meters on top. Now, if you haven't memorized this yet, go to materials and open up the metric table that I gave you from yesterday. You'll open that up, you'll look through that, and you'll find centi. And what you'll see is that 100 centa of anything, centiliters, centigrams, centimeters, 100 centimeters equals 1 meter. So now when we do the math here, centimeters will cancel out. On top, 200 times 1, we end up with 200 over 100. 200 over 100 just equals 2. So group B didn't make a mistake. Group A and B got the same thing. Now let's check out these guys, group C. Let's turn 2,000 millimeters into meters. So what we'll get here, let's put millimeters on bottom so it goes away, put meters on top, and look at your table. Millimeters equals how many meters? Well, it's 1,000 millimeters equals 1 meter. And so millimeters cancels out. And so we end up with 2,000 meters over 1,000. And 2,000 over 1,000 just gives us 2. So we get 2 meters once again. So see, all three groups measured the same thing, and they actually got the same values. They just used different units. Okay, what has more mass? A 350-gram box of chocolates or a 2.5 kilogram box of chocolates? So what's bigger? So if somebody's walking down the hallway, whenever this COVID stuff is over and we're back at school, maybe I'm using this video years from now when the COVID thing is gone. If somebody's at school, they offer you a box of chocolates, they say, hey, you can get 350 grams, or you can get 3.5 kilograms. Which one are you going to choose? Let's go ahead and convert kilograms over to grams. So just make a conversion factor. Get the unit on bottom you're getting rid of and the unit you want to turn into on top. And now open up your table, look at what it has for kilo, and then you'll see that it's 1 kilo equals 1,000 of grams, meters, liters, whatever you use. So now kilograms will cancel out, and what we'll have is 3.5 times 1,000 divided by 1. Right? So just multiply the top, divide by what's on bottom. So 3.5 times 1,000 is going to give us 3,500. So the answer is 3,500 grams. So somebody offers you that, take the 3.5 kilograms. All right, now let's move on to where we have multiple steps. What's going to happen, what I've been doing is I've been having the unit you want to start with. I've been having you make a set of parentheses, put the unit you need to get rid of, the unit you turn it into. But what we're going to do, instead of using that system, we're going to do what's called bridge notation, where we're going to draw a grid like this. We'll start with whatever we want, whatever the problem gives us, and we can put that and turn it into another unit. Then do another problem, turn that into another unit. And we can do this as long as we need. Now, some of you might know some tricks to get past this and not do the bridge notation I'm teaching you. The important part of today is not converting years to seconds. That's not the skill I want you to gain. I want you to gain the ability to use bridge notation for any units, because down the line, we're going to have these long, difficult problems where you're converting grams of one substance into the moles of another substance, into the moles of another substance, and using a chemical equation and all this stuff where it's going to be very confusing if you're not good at using what I'm showing you right here. So for bridge notation, let's convert 132,540 centimeters into kilometers. So this, we're going to go all the way to kilometers. Now, here's what you'll encounter. We have centimeters. Look at your chart. Does your chart turn centi straight into kilo? No, it doesn't. So what we have to do here, we have to turn centimeters into plain old meters. And your chart shows you that there's 100 centimeters in a meter. Now that we're in meters, let's turn meters into kilometers. And we can see that there are 1,000 meters in 1 kilometer. So you see we have a two-step problem here. You know what? I think there's a glare right in your face. Let me scoot this a little bit. See if this helps. So we need to turn centimeters into kilometers. It takes 2 steps. So look what we have. The centimeters cancels out. The meters cancels out. And you're left with kilometers, which is exactly what you wanted. Now multiply everything on top. And so you'll end up with 132,540 divided by, let's multiply the stuff on bottom. 100 times 1,000 divided by 100,000. Okay, see how that works? And so what's going to happen when we do this? We're going to end up with 1.32540 kilometers. That's our final answer. So that's how we can turn this from centimeters into kilometers. Okay. I'm going to actually, for the sake of time, I'm going to skip 350 milligrams, kilograms. Let's go how many seconds are in a week. So we start with 1 week. We need to turn this thing into seconds. All right, so what can we turn a week into to begin with? Well, we can turn a week into days because there are 7 days in 1 week. What can we turn day into? We can turn day into hour. There are 24 hours in 1 day. And then what can we do next? We're trying to go all the way to second. We can then turn hours into minutes. There are 60 minutes in 1 hour. And then lastly, we can turn minutes into seconds because there are 60 seconds in 1 minute. Let me make sure this view works for you guys. Can you see with the glare? Okay, so that I got a glare. All right, let me fix that. Okay, so I think right there you can see it okay. Me. Okay, there we go. Now you can see what I'm actually doing. Okay, so you set it up like that. So you turn a week into days, days into hours, hours into minutes, minutes into seconds. Okay, so when we do that, the weeks cancel out, days cancel, hours cancel, minutes cancel, and our final answer will be in seconds. And what we have on top is 1 times 7 times 24 times 60 times 60. And look on bottom, it's a whole bunch of ones divided by 1. That's not going to make any difference. All right, you see how that works? And so we have 1 times 7 times 24 times 60 times 60, and we get 604,800 seconds. So that is what we get when we have 1 week turned into seconds. So this is bridge notation right here. I want you guys to get used to using this. So on your homework, you're going to have some questions where you have to pull up the metric table, and you'll have to try to use this, these kind of problems using the metric table. You will also have a few using things you should be more familiar with, like hours and days and that kind of stuff. What I'm doing, I did all these examples up front, and then I want you guys to try these problems without me showing you the answers on it. Okay, so it's going to be low, and also there's no multiple choice, so no guessing either. You got to input the correct answer. So I really want to see how you guys understand this. We will spend a little more time on Monday. I'm going to add a few steps to this, but I want to gauge how you do on this without me showing you the answers this time. So do your best, try to answer these questions, and as always, let me know if you guys have any questions. Just email me, and if you need tutoring this afternoon, I will be available. All right, guys, have a good day.